In this video, we're going to talk about how to solve compound inequalities. A compound inequality is two inequalities joined by and or. Okay. Examples. Write a compound inequality that represents each situation and graph the solutions. A. All real numbers that are at least -1 and at most 3. So at least means greater than or equal to, and at most means less than or equal to. They cannot be any more than 3 and they cannot be any less than -1. So we're looking for all the numbers that are at least -1. So that would be everything from -1 to the right, but no more than 3. And that would be 3 and everything to the left. So my graph is where those two overlap. So at least -1 would be from -1 all the way to the right, and at most 3 would be 3 everything to the left. So we're looking at that overlap in the middle. All right, example B. All real numbers that are less than 5 but greater than -1. So we're looking for all the numbers that are less than 5. So we're starting at 5, less than 5, but also greater than -1. So that would be -1 to the right. So we're looking for the numbers less than 5 and greater than -1. That's everything in between these two. And they're open circles because they're not less than or equal to or greater than or equal to. All right, number 2, solving a compound inequality containing and. So we're solving 5 is greater than 5 minus f is greater than or equal to 2. So our directions say write the compound inequality as two inequalities joined by and. Solve each inequality separately. Rewrite the solution as a compound inequality and graph your solution. So right now I have 5 is greater than 5 minus f is greater than or equal to 2. So we're going to split this up. 5 is greater than 5 minus f, and 5 minus f is greater than or equal to 2. So in order to solve this, I'm first going to subtract 5 from both sides, and that leaves me with 0 is greater than -f. I'm going to divide both sides by -1, and I have 0 is less than f. Remember, dividing by a negative, I have to flip that symbol around. All right, solving the other inequality, I'm going to subtract 5 from both sides. So I have -f is greater than or equal to -3. And I'm going to divide both sides by -1. So I have f is less than or equal to 3. So if I combine these two back together, I have 0 is less than f, and f is less than or equal to 3. So I have an open circle on 0, and I'm looking for all the places where 0 is less than f, or f is greater than 0. So that's everything in this direction. And I'm looking for all the places f is less than or equal to 3. So that would be everything in this direction. So the numbers that satisfy that are 1 and 2 and all the decimals in between there. All right, number 3, solving a compound inequality containing or. So I'm solving 3x plus 2 is less than or equal to -7, or -4x plus 5 is less than 1. So our steps say write the compound inequality as two inequalities joined by or. Solve each inequality separately and rewrite the solution as a compound inequality and graph your solution. All right, so I have 3x plus 2 is less than or equal to -7, or -4x plus 5 is less than 1. So again, solving each one separately, I'm going to subtract 2 from both sides. So I'm left with 3x is less than or equal to -9. Divide both sides by 3, and I have x is less than or equal to -3. Or I'm going to subtract 5 from both sides. So I have -4x is less than -4. divide by negative 4, divide by negative 4. And when I divide by a negative, I flip my sign, so x is greater than 1. So it can be either this situation or this situation. So x is less than or equal to negative 3. That looks like this. Or x is greater than 1. So that would look like this. And either one of those would make the inequality true. All right, let's look at a couple of special cases here. Sometimes funky things happen when we solve compound inequalities. So in this example, I have negative 6n minus 2 is greater than or equal to negative 8. And I have 3n plus 7 is less than or equal to 28. So if I solve this, this is linked by an and, I have adding 2 to both sides. I have negative 6n is greater than or equal to negative 6. I'm going to divide by negative 6 and divide by negative 6. So that gives me n is less than or equal to 1. Alright, and solving this inequality, I'm going to subtract 7 and I'm going to subtract 7. So I have 3n is less than or equal to 28 minus 7, which is 21. And I'm going to divide by 3 and I'm going to divide by 3. So I have n is less than or equal to 7. Alright, so let's take a look here. I'm going to use some highlighters to kind of illustrate this. So n is less than or equal to negative 1. Before, when we had an and statement, we ended up with a graph that kind of looked like a little section of the number line. Okay? So in this case, n is less than or equal to negative 1 is here, and it's everything in this direction here. Okay? 7, which isn't on my number line, but is way over here, is all of this. We are looking for the place where these overlap when you have an and statement. So we're looking kind of at this orange spot. So my answer to this inequality is just going to be this bit here. And I'm going to get a Sharpie so you can see this a little bit better. Because they overlap forever, my solution is actually just going to be n is less than or equal to 1. And there is no compound inequality for my solution. So what happened is the solutions overlapped in the left direction. That's going to continue on forever and ever and ever to the left, from 1 all the way to the left. So we're not ending up with that little section of the number line like we did before with an and statement. We actually end up with a different kind of solution here. All right, let's look at this second example. I have 5 minus 4n is less than 5, and 2n plus 4 is less than or equal to negative 6. Alright, so I'm going to solve each one separately. So on this side, I'm going to subtract 5 from both sides, and I'm left with negative 4n is less than 0. I'm going to divide by negative 4, and I'm going to divide by negative 4. So I have n is greater than 0. And if I solve this one, I'm going to subtract 4 and I'm going to subtract 4. And I'm left with 2n is less than or equal to negative 10. Divide by 2, and I have n is less than or equal to negative 5. So if I look at n is greater than 0, that's here. And if I look at n is less than or equal to negative 5, I don't know why I wrote 15, that's here. Notice that there is absolutely no overlap. So the answer to this is no solution. Okay, so when there's no overlap in an and statement, there is no solution to that inequality. All right, last example for some special cases. I have negative 4k minus 5 is greater than or equal to 23, or negative 2k minus 10 is less than 4. This is an or statement, so this one's a little different. Normally when we have an or statement, we're looking for a graph that kind of looks like this. So we have two arrows pointed in opposite directions, okay, with a kind of a break in the middle. So this is your typical or solution. All right, coming back over here. All right, I am going to start by adding 5 to both sides. So I have negative 4k is greater than or equal to 28. I'm going to divide by negative 4. And that gives me k is less than or equal to negative 7. Or, notice I flipped that symbol, right? Divide by a negative. Add 10, add 10. I have negative 2k is less than 14. Divide by negative 2, divide by negative 2. And I end up with k is greater than 7, negative 7. All right, so if I'm looking for k is less than or equal to negative 7, let's see. Make sure I did that right. Add 5, add 5. Yeah, that would be, say negative 7's over here. That would be everything in that direction. If I'm looking for k is greater than negative 7, that's everything in this direction. So notice that my whole number line is highlighted. And since this is an or statement, it can either fall in this, your answer can either fall in this yellow or in this pink and satisfy the compound inequality. So we highlighted the entire number line, which means that your answer is all real numbers. So what happened? The entire number line is highlighted in an or statement. Okay, so again, when you're highlighting the entire number line in an or statement, your answer is all real numbers.